Hello, and welcome back to Shiksha DaCosta. Today we're going to start a unit on using linear systems to solve problems. In this unit, we're going to learn how to find and how to interpret something called the point of intersection between two linear relations. And you're good at this when you can take up a problem and you can model it and then solve it if that problem involves the intersection of two straight lines. So to start us to get our minds on the right track, I'd like to point you out to one of my favorite games, Mario Kart. In Mario Kart, a racer can actually get a speed boost if you press on the accelerator button at the correct time at the start of the race. And pro tip, that time is when the number 2 is the biggest. Yoshi does so, and as soon as the race begins, he is 10 meters ahead of the other racers thanks to that speed boost. Peach missed the boost, but Peach has a faster cart. The cart that she chose was better. Yoshi's cart can go 24 meters per second, while Peach's can go 26 meters per second. So we know that Peach is faster. If they were to keep up these speeds, how long would it take before Peach actually overtakes Yoshi? This is the question that we're going to be examining to help us figure out what the heck is this point of intersection stuff, okay? So what is happening here is there are linear relations, right? Both of these racers, we can measure their distance, how far their carts have been driven, how the distance that they have traveled, compared to time, the number of seconds that have passed. Right? This is a relation between two quantities, distance traveled and time. And both Peach and Yoshi both have two different distance travels over time. So on a graph, we can label this, right? We can say that, okay, this is my d-axis for distance traveled. This is my t-axis for time that has passed. So as soon as the race begins, Yoshi is 10 meters ahead. So what I know now is on the t-axis, when time is 0, that's as soon as the race begins. Yoshi is already 10 meters, has traveled 10 meters, whereas the other racers have not traveled at all, right? So that's because Yoshi got that boost at the start. So the distance, the d-intercept, the point where Yoshi's relationship will cross the d-axis will be at 10. So I can put that right down here at 10. Now what about Peach? Well, Peach has a d-intercept as well. When the time is 0, how far has Peach traveled? Well, we know that she missed the boost. So whereas Yoshi got 10 extra meters out of that boost, Peach got none. So in 0 seconds, Peach has traveled 0 meters. And we can put the d-intercept for Peach at 0, 0. Now, we know that linear relations have two parts, not just a y-intercept, or in this case a d-intercept, but they also have a slope. So in this case, Yoshi is going 24 meters per second. So every time that the time increases by 1 second, Yoshi's distance increases. Yoshi's distance goes up by 24 every single time. So if I go across to the right by 1 second, I have to go up 24. Whereas for Peach, every time 1 second passes, she covers 26 meters. So she would go up by 26. So the relationship that connects Yoshi's distance and time, what would that look like algebraically? So can we come up with equations to describe Yoshi and Peach's distance in terms of time? So to answer a question like that, you have to recognize that all these are linear relations because there is a constant rate of change, right? Their distance is constantly changing by the same amount. And so we know that this is going to be a linear relation, and all linear relations look like y equals mx plus b. And we remember this, that the m in mx plus b is the slope, whereas the b in mx plus b is the y-intercept, or in this case, the d-intercept, right? Instead of y, we'll be using d, and instead of x, we'll be using t. So what are their equations going to actually end up looking like? For Yoshi, it's going to be Yoshi's distance is equal to 24 times t plus 10. We can see right over here, there we go, that's our d-intercept of 10. And then 24t, that is the slope. Now that we know Yoshi's, Peach's is a little easier to come up with ourselves. Peach's is simply the distance is equal to 26t, right? Again, here is the slope, and let me highlight these for you so it's a little bit easier what these are. That is the slope, 24 and 26. And over here is our d-intercept plus 10 for Yoshi. But there's nothing there for Peach. Why not? Well, plus 0, what would be the point of writing plus 0 for something? Right? Adding 0 doesn't really change anything at all. And so therefore, Peach's equation is just 26t. So let's start to graph these lines. So what I'm going to do is, now that to graph a line, you need just 2 points, right? And you can connect those 2 points with a straight line. So what I'm going to do is I'm going to look for 10 seconds. At 10 seconds, how far has Yoshi driven? And at 10 seconds, how far has Peach driven? And I'm going to plot those points over here, somewhere along this line. Well, it's pretty easy. All we have to do is take this, this equation here for Yoshi, which I think I don't need the highlights anymore. So I'm just going to erase those because I'll need those colors available. We'll take the equation here for Yoshi, and we know that at 10 seconds, t is equal to 10. So this t value here is equal to 10. So what does d end up equaling when we do 24 times 10 plus 10? Right, 24 times 10 is 240, plus 10 is 250. So after 10 seconds, Yoshi has traveled a total of 250 meters. Well, I'm going to plot this point here before I move on to Peach very quickly. So the x value was 10, or instead the t value was 10. So I know I'm going to be here on the t axis. I'm going to be right there. The distance, the d value, equaled 250. So that's all the way up here somewhere. So let me see. Over there's 10, which means I can put my point right there at 10 and 250. That's Yoshi. That's for Yoshi. But for Peach, all I have to do is plug in 10. 10 times 26 is 260. So again here, 10 on the t-axis. The t value is 10. But the d value is 260. So that'll be a little bit higher than this. This was 250. 260 is probably like right there. So let's plot that point down as well. And now what we can do is connect these with straight lines, just like this. Notice that the red goes to the orange, the blue goes to the yellow. The red to the orange, that's Yoshi. The blue to the yellow, that's Peach. So we can clearly see that after just 10 seconds, Peach has already regained the lead. Peach has traveled a distance that is more than Yoshi. Yoshi got that boost and Peach is still ahead of him. So the question then becomes, what is happening right over here? Right where the lines touch, what is going on there? What does it mean in the context of this problem, or in the context of this situation? What does it mean when these two lines touch each other over here? So you may be thinking over here that Yoshi and Peach maybe had a collision because their lines are touching. That means maybe their carts hit each other. That's not necessarily true. Okay, what it could mean, what is happening here, and another thing that you may think is they're going the same, they're right beside each other because they're going the same speed. They are not going the same speed, because we can see here that Peach Peach's speed is still 26, and Yoshi's speed is 24. That stays the same for the whole race. So Peach is still going faster than Yoshi at this point. And how do I know that? How do I know what characteristic of this line tells me that Peach is going faster? Well, Peach's slope is steeper. Peach's slope is a little bit steeper than Yoshi's. It's going up. The distance that she's covering is more for every unit of time. So in 10 seconds, Peach has covered a greater distance. That tells me that she's driving faster. So what is going on over here? If their speed is not the same and they haven't bumped each other, what this just means is they have driven the same distance over here. Okay? What is that distance? So right over here, if we go straight down, we can see that at 5 seconds, their distance is both 130 meters. Now, that doesn't mean that they've bumped into each other. They could be sort of like side by side, and both have driven 130 meters. In fact, they could be side by side. They could, at that point, Peach is overtaking Yoshi. Peach's speed is faster, and they're at the same position. So even if 1 second passes, Peach will cover more distance. So Peach will go is going a little bit faster than Yoshi here, and this is the point where Peach can overtake him. Exactly at 5 seconds. So that's what we mean when we say that the point of intersection of a system of linear relations can help us understand what's going on. This is a system of linear relations. A system means more than one. So here we have a linear relation for Yoshi and a linear relation for Peach. A point of intersection in a linear relation is a point where both relations have the same x value and the same y value, or the same whatever the variables are. In this case, the time was the same at 5 seconds, and the distance was the same at 130 meters. When the time is 5 seconds, if the race was only 5 seconds long, then it would not matter whether you chose Yoshi or whether you chose Peach. You would be at the same distance at that point. If the race was less than 5 seconds long, then Yoshi is ahead of Peach for all of that time. And if the race is more than 5 seconds long, then of course Peach is ahead of Yoshi for all of that time. Which means that that'll tell you which is the best racer to pick depending on the length of the race. Now, races in Mario Kart are often longer than just 10 seconds, but this is just an example of how we can think about linear relations and connect them to our everyday life. Speed, distance, and time are a fantastic way to compare, are fantastic quantities to compare to help us understand algebraic equations of graphs. So just to go over sort of what these systems of linear relations could look like, okay? Because there's 4 situations you might find yourself in. Remember, a system of linear relations is when you have more than one linear relation, so 2 or more. Usually we talk about it when we're talking about 2. A point of intersection is a coordinate where 2 lines have the same x value and the same y value. What does that look like on a graph? Well, if you have 2 lines, remember both lines have to look like y equals mx plus b. There's a slope and there's a y-intercept. Well, if both lines have the same slope and they both have the same intercept, well then that's the same line that you're talking about, my friend. Every single point on the red line will overlap every single point on the blue line, or will overlap a point on the blue line. They are the same line. They're perfectly one on top of each other because the same y-intercept means they're starting at the same point, let's say right here, and the same slope means they're both heading in exactly the same direction. Well, what if they have the same slope, but they have different y-intercepts? Well, that just means that this point, the point where they're starting, is going to be different, but they are still, the slope tells you the direction. So they are both going in the same direction. So that kind of looks like this, where the lines would look like they are parallel. Parallel means in the same direction. So these lines have different y-intercepts, but they're both going in the same direction, which means that they will never ever touch. They will never have a point where they intersect. There's never going to be a point of intersection between two lines that have the same slope. Okay, well, let's go back to the same y-intercept. What if they have different slopes, but the same y-intercept? Well, that means that they are starting at the same point, let's say over here, but they will be heading in different directions. So you can see here, both these lines have the same y-intercept, but they're going in different directions. What does that mean for their point of intersection? Well, if they have the same y-intercept, then both of them obviously meet. Their point that they intersect is on the y-axis. It's going to be at 0 and then whatever the b value is. And finally, the most complicated situation. What happens if you have two lines and they have different slopes and they have different y-intercepts? Unfortunately, this is the most common situation you'll find yourself in. And that kind of looks like this, right? Both of these lines have a different y-intercept and they're both going in different directions. So eventually they will meet. They're not like parallel lines that will never touch each other. They are not like these lines which meet at the y-intercept. They will meet at some point, but we don't know what that point is. We can find out in a few ways. So for linear relations that are in slope-intercept form, the slope always tells you how quickly the dependent variable changes every time the independent variable increases by 1. And the y-intercept is always the place where the linear relation starts. It's like the initial value, the starting point. The point of intersection is actually a point between two different linear relations where x and y, or whatever the two variables are the same. In other words, if you put in that value of x into either of these two linear relations, both of them will give you the same value for y. You can graph both linear relations on the same set of axes, and you will see that the point of intersection is literally the point where those two lines touch each other, where they intersect. Now, in this unit, we will learn how to find that point of intersection without graphing technology or without graphing it by hand. We'll explore how to find it algebraically. So let's do an example here. Roger and Bell are trying to decide on a home internet provider. The providers in the region, they charge for every single gigabyte that you use, and they also have a base monthly rate that you have to pay no matter what. Which of these providers would be the best to use? Take a look at this, think about it for a little while, figure out which one do you think would make the most sense that you would go with if you were Roger and Bell. Well, to really come up with an answer, you might be thinking, okay, I'll go with Minty because they have the lowest base rate. Or you might say, oh, I'll go with Landback because they don't charge me per gigabyte used. I just have to pay once and then forget about it. Or you might say, oh, I'll go with Tech Savvy because it's something in between the two. If I do go over my, my limit, or if I use a lot of gigabytes this month, I won't have to pay that much. And if I don't, then I'll get a nice little discount. Well, using linear relations, we can figure out which situations would be the best for which provider. And in each case, no matter which provider you go with, there are two quantities that we are comparing, right? We are looking at the total cost, and the total cost depends on the amount of gigabytes we have used. So if I were to graph this out, the cost would be on my vertical axis, C, because that depends. It's the dependent variable. It's the variable that depends on the other one. This one is independent. I control how much I go on the internet. I don't control the cost. However, if I control my usage, that will affect the cost. So I can control the cost indirectly. In other words, usage is my independent variable and cost is my dependent one. So when I'm coming up with equations for each of these three, it's pretty easy. We know that the cost for every gigabyte is our slope, because every time the gigabytes increase by 1, the cost increases by this amount. And the base rate is the amount that I will pay even if I use 0 gigabytes. So even if I'm at 0 here, I will still pay this amount, which means that this is my intercept. So the equations are right here. So the cost for tech savvy is 0.05 multiplied by U. So this is 5 cents times the number of gigabytes plus $50 no matter what. Even if U is 0, 0 times this is 0 plus 50 is still 50. So that's the base rate. For Minty, it is 15 cents per gigabyte times the number of gigabytes plus $40. And for Landback, it is 0 times U plus 60. So I don't really need to write 0 times U at all. I can just write the cost is going to equal 60 no matter what. This is what they look like if I were to graph them. Okay, so I've used graphing technology to graph all of these, and these are the lines, the graphs that represent these linear relations. So here we see tech savvy, it starts at 50, and the slope is in the middle of these two, right? So we can see that Minty has the highest slope of 0.15, which is how we can see that the line is going up the fastest. It also has the lowest base rate at 40. So that's the C-intercept. Landback has a slope of 0. So we can see that that is going to create a horizontal line. And it has a cost, a C-intercept of 60. In fact, that's the cost the whole time. And tech savvy, like I mentioned, is in between. It starts at 50, and then it doesn't increase as fast as Minty. It's not flat like and horizontal like Landback. It increases at a slower pace. So it's sort of in between the two. How does this connect to points of intersection? In other words, how can systems of linear equations help us solve this problem? Well, let's look at all the places that these relations intersect each other. Going from left to right, the first place that they intersect each other is here. This point of intersection is at 155. Okay, the x or the u value is 100. The c value is 55. In other words, when the usage is 100 gigabytes, these two lines that are over here, the purple and the blue line, they both have the same y value. They both have the same, c value of 55. So when you have used 100 gigabytes, Tech Savvy and Minty both cost $55. Landback is still up here at 60. Well, what about the next point of intersection? So the next time I see again, just going from left to right, the next time I see them intersect is right there. So the point of intersection here is 133.33 and 60. So what does that mean? When we're using about 133 gigabytes, Minty, which is in blue, and Landback, which is in green, they both cost the same amount. They both cost $60. Tech Savvy, though, is still the cheaper option at this point because it only costs $56.67 for using 133 gigabytes. And if you want to double check that, you can always plug in 133 into all three of these values and see what the cost will end up being. Okay? They will end up being 60 for Minty and Landback and 56.67 for Tech Savvy. The final point of intersection over here is at 260. So this is what this means is when you use 200 gigabytes, Tech Savvy and Landback both cost $60, whereas Minty now costs $70. $70. And you can find that out just by plugging 200 in here. 200 times 0.15 is 30. 30 plus 40 is 70. Okay? So this is how points of intersection will help us figure out which is the best internet provider for us. What you can do is look at what Roger and Bell can do, I guess, is they can look at their usage. How many gigabytes do they use every month? Well, if their usage is between 0 and 100, so between 0 and 100, the line that is the lowest in terms of cost, the line that has the lowest C values is going to be Minty. Okay, because it starts off at the lowest base rate and it increases. Sure, it does increase. Eventually, it's going to pass the others. But we know that when is it going to pass the others? It's going to pass them after you use 100 gigabytes. So if you don't use a lot of internet every month, if you use less than 100, then we can see that Minty is the best choice. Well, what if you use more than 100? Well, we can see here that between 100 and 200, tech savvy is the linear relationship that gives you the lowest C values. So between 100 and 200, tech savvy is the best choice. And finally, if you are using more, if they look at their monthly history and they can see they use more than 200 gigabytes every single month, they watch a lot of TV on their streaming services, they download a lot of things, maybe they upload a lot of things. Well, if they're using more than 200, then land back would be the best choice, because land back only charges $60 as a flat rate. So that's the end of this question here, right? When the usage is between 0 and 100, we can see Minty is the best choice. Between 100 and 200, tech savvy is the best choice, and after 200, land back is the best choice. When the usage is exactly 200, then either tech savvy or Minty would be a totally fine option, because both of them cost the same. If your usage is exactly 200, then tech savvy or land back would be fine, because both of their costs are the same. So we figured out in the context of a problem like this, where you have several things that you're comparing, and each of those things form a linear relation, you can graph all of those lines and look for the points of intersection to help you understand which would be the best in which context. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.